Propositional Logic Part 1, Logical Operators and Translations. This presentation is based on Chapter 7 of the textbook Logic by Stan Baronet, published by Oxford University Press. Propositional logic is the part of logic that analyzes arguments whose basic components are whole statements or propositions. It can be contrasted from predicate logic, which looks at arguments whose logical structure relies on parts of individual statements. The logical operators shown to the right are symbols used to translate logical terms from ordinary language. The ordinary language terms not, and, or, if, and if and only if. So we translate these into the logical symbols. And these logical operators connect whole propositions as opposed to parts of propositions. In this presentation, we'll be looking at each of these operators and their symbols in more detail. So first, it's good to distinguish between simple and compound statements. A simple statement is one that doesn't have another statement or a logical operator as parts or components. So for example, he ate a ham sandwich. When we're translating a simple statement into symbols, logical symbols, we use any capital letter from the Roman alphabet from A to Z. It doesn't matter which letter we use as long as we're consistent within one argument. When we're translating one argument, once we've chosen a capital letter for one statement, we have to keep that letter as the translation for that statement wherever it occurs in the argument. Even though we are allowed to choose any letter we want, it's customary to choose a letter that has the same letter as the first letter of one of the important words of that statement. So in this case, the H helps us remember the word ham. A compound statement is one that has at least one logical operator and at least one simple statement as components. Now, most compound statements will have multiple simple statements, but there can also be a compound statement that's just one simple statement and the negation. But here's an example of a compound statement that has two simple statements joined by the and operator. He ate a ham sandwich and he ate tacos with carne asada. In this case, we're using the H to symbolize the statement he ate a ham sandwich, and the T to symbolize the statement he ate tacos with carne asada. The dot is the symbol for the and logical operator. The first logical operator that we're going to look at is the negation. This is a not statement, which is used to deny the truth of a statement. The negation operator is symbolized by a tilde. So here are some examples. I am not a crook. We could symbolize that with tilde C. It's false that Clinton is president. We could symbolize that by tilde H. In this case, H is being chosen because we've already used C on this slide to represent the statement, I am a crook. So we're using H to represent the statement, Hillary Clinton is president. Another example, it's not the case that orange is the new black. We could symbolize this by tilde O. So let's look at that last statement. We can see the negation or tilde is a translation of the clause, it's not the case that. So the word not, the phrase it's false that, or the phrase it's not the case that can all express the same logical idea of a negation. That's true of all the logical operators, even though we only use one symbol to describe the negation because it's the same logical concept. Because of the flexibility of natural languages like English, that same logical idea can be expressed in many ways. So you have to be on the lookout for the meaning of a statement. Another example is the use of contractions in English. So the example under the picture on the right, this isn't a pipe. The N''T stands for not, but that's expressing the idea of logical negation. So we would translate this statement as tilde P. Remember, the P stands for the statement, this is a pipe, without the negation. And that's basically whenever you have a logical operator not, if, and, or, you cannot include that as part of the meaning of your capital letter. The capital letter is only going to stand for a simple statement without the operator. So in this case, the P is standing for the simple statement, this is a pipe. Tilde P stands for the compound statement, this is not a pipe, or this isn't a pipe. The second logical operator we're going to look at is the conjunction. This is an and statement that joins two statements called conjuncts. And the idea of the conjunction is not saying that either of those is false, it's rather saying that both of them are true. Here are some examples in ordinary language. Both Los Angeles and San Francisco are in California. The first capital letter L stands for the statement Los Angeles is in California. The second capital letter F stands for the statement San Francisco is in California. You'll notice because of the flexibility of English, we do not have to rewrite that whole predicate is in California twice. If you wanted to, you could rewrite this statement in English for clarity. Both Los Angeles is in California and San Francisco is in California. This is an abbreviated form that's basically less repetitive. But you have to use the dot to stand for the conjunction operator. She likes Star Wars, but she prefers the Marvel Cinematic Universe. So in this example, the word but is expressing the idea of and. The logical idea of and, or conjunction, is just saying that both statements you're conjoining are true. And if you think about the word but, it does have a different connotation or implicit meaning than the word and, but it has the same basic idea logically speaking. When you say she likes Star Wars, but she prefers Marvel, you're saying she likes Star Wars and she prefers Marvel. Both of them are true. The other layer of meaning that's being added is that the second conjunct, she prefers Marvel, may go against expectation. Or in this case, it's adding a clarifying fact. She likes Star Wars and she also prefers Marvel. So in terms of logic though, the but is translated with the dot, the same as an and. And in this case, the capital W stands for she likes Star Wars, and the capital M stands for she prefers the Marvel Cinematic Universe. He likes working at Amazon, however, he wants to work at Google. Similar to the last example, but in this case, the word however is expressing the logical idea of and, or conjunction. It's similar in usage to the English word but. It can express a conjunction where the second conjunct may add additional information or otherwise go against expectation. Another example from the picture, he ordered ramen and sushi. Similar to the first example, the part of the second statement is abbreviated. He ordered ramen and he ordered sushi would be a more complete way of expressing this. But to avoid the unnecessary repetition in the natural language English, you can drop out the first part of that second statement. The third logical operator is disjunction, and this is symbolized by a wedge. You can think of it as a simplified V without showing variation in thickness or serifs, unlike a typical font that would be expressing the V letter. So in the disjunction or statement, you join two statements that are called disjuncts. And like the conjunction, the order of the disjuncts doesn't matter. If you change the order of conjuncts, A and B versus B and A, or if you change the order of disjuncts, A or B versus B or A, it's the same basic idea logically speaking. But let's look at some examples of the disjunction. Either Roberto or Tori will present the proposal. Now sometimes with disjunctions you have the word either before the first disjunct, but it's basically optional. The logical idea is going to be the same regardless of whether you have just or also either or. In this case, we have R symbolizing the statement Roberto will present the proposal, and T symbolizing the statement Tori will present the proposal. The predicate, or the second part of that statement, has not been added to the first disjunct because it doesn't need to be repeated. We can basically abbreviate it in English and express the same logical idea. But it's good to be on the lookout for those things because you'll have to be aware when you're translating the letter R does not only stand for the word Roberto. R stands for the whole statement. Roberto will present the proposal, because each of our capital letters has to stand for a complete statement, something that can be true or false. A second example, Apple or Samsung will be the dominant manufacturer of mobile phones. So similar issue as to the first example, the first disjunct is abbreviated as Apple. A more complete way of saying this would be Apple will be the dominant manufacturer of mobile phones, or Samsung will be the dominant manufacturer of mobile phones. But when you hear the unabbreviated form, you can see it's kind of lengthy and repetitive, so that's why it's more efficient in English to drop the predicate from the first disjunction. But logically speaking, we need to remember that the capital A stands for the entire statement, Apple will be the dominant manufacturer of mobile phones. Another example, the Republicans will win the election unless the Democrats get out the vote. So in this case, we have the word unless instead of the word or. Unless can basically be regarded as equivalent to or, logically speaking. This statement is saying either the Republicans will win or the Democrats get out the vote. So that's why you can translate it with the wedge or logical operator. I will get a dog or a cat as a pet. So in this case, the capital D stands for I will get a dog as a pet, and the capital C stands for I will get a cat as a pet. So both of those have been somewhat abbreviated, both the first and second disjunct, to avoid repetition. But it's important to remember, as before, what the actual statement being referred to by each capital letter. There are at least two different ways we can use the word or. This is called the difference between inclusive and exclusive disjunctions. An exclusive disjunction is one in which both disjuncts cannot be true at the same time. So it's saying one and only one of them is true. If one is true, the other is not true. An example of the exclusive use of or happens when you are ordering a meal at a restaurant. If the restaurant gives you a choice of sides, typically you can only have one of those sides but not the other. So for example, you can have soup or salad as a side. If that's what the restaurant is telling you, it doesn't mean you can have both. If you order the soup, you cannot have the salad. If you order the salad, you cannot have the soup. So this is an exclusive or. Inclusive or means both can be true and the whole disjunction is still true. So an example from ordinary language, I will eat eggs or bacon for breakfast. If someone says that to you and then later you ask them and it turns out they ate both, you wouldn't say that they were speaking falsely initially. They were probably using the word or inclusively to mean that I will eat eggs for breakfast or bacon for breakfast and perhaps both. In logic, we have to choose which one of these we're going to use as the general meaning of or. And for various reasons, basically it allows us to be more flexible in translation. Logic uses the inclusive meaning of or. You can express the exclusive or, but you have to use the or wedge operator plus an additional statement. But basically, whenever you see just the or just the wedge, remember that it's expressing the inclusive or, so it's possible for both of the disjuncts to be true. The next operator we're going to look at is the conditional. This is symbolized by a horseshoe. The conditional is an if-then statement. It joins one statement called the antecedent, which follows the if, to another statement called the consequent, which follows then. Now, when this is expressed in ordinary language, specifically English, you will not always have then, although you will usually have if. Let's look at a couple of examples that express the different ways the conditional can be expressed in the natural language English. If the plant gets enough sunlight, then it will grow. So this is a pretty straightforward case. We have both if and then. The word if indicates the antecedent or if clause, and the word then indicates the consequent or then clause. The term antecedent indicates before, ante, and so that's a way of remembering that the antecedent or if clause comes before the horseshoe. And most often, not always, but most often it comes first in the sentence in English too. You have if usually before you have then. So what we do is we choose a capital letter to symbolize the first statement, the plant gets enough sunlight. In this case, we've chosen S. We put that before the horseshoe. Then we choose another capital letter to indicate the consequent, which is it will grow. In this case, we've chosen G for that statement. And so when we take it together, the translation is S horseshoe G. Let's look at another example. You will get an A in the course if you earn 900 points or more. In this case, the if occurs in the middle of the English sentence. But we have to remember that the clause that follows if is actually the antecedent. So even if appears in the middle of the statement, the clause that follows the if has to go before the horseshoe. So we look at the statement, you earn 900 points or more, and that is being translated by the capital letter E. The first statement that appears in the sentence is you will get an A in the course, and that's being translated by the capital letter A. However, even though the A occurs first in the English sentence, the logical idea has to be predominant in our translation. So we look at the if clause, if you earn 900 points, and we realize the E has to go before the horseshoe because it is the antecedent. Another example, if your date looks bored, then he doesn't like you. So in this case, it follows the usual ordering. We have the if clause first, the then clause after. So the capital letter B stands for your date looks bored. The capital letter L stands for he does like you. Because we have another logical concept in the consequent, the not for doesn't, we have to add a tilde there. This is our first example of using more than one logical operator in one statement, and we'll give many more examples of this in the coming slides and lectures. But it shows you that yes, you can have more than one logical operator in one logical formula or expression. And basically there's no limit, there's an infinite number of possible operators you could have in any one statement, but typically these are limited, practically speaking, because of the typical limit of human thoughts and human sentences. So now let's look at the difference between if and only if. There's actually even more variability in how you express a conditional proposition than just whether you include then or whether if comes at the beginning or the middle of a natural language sentence. So if alone means the if clause. It indicates the antecedent, and whatever follows the if goes before the horseshoe. But there's also the phrase only if. And only if has a different meaning than if. Only if does not indicate the consequent, does not indicate the antecedent. In fact, only if is kind of like the word then. It usually indicates the consequent of a conditional. Therefore, whatever follows the phrase only if goes after the horseshoe. Let's look at some examples. You can have some porridge only if you eat your meat. So you can look at the only if as being equivalent to then. What follows only if you eat your meat has to come after the horseshoe. So in this case, we look at the you eat your meat and translate it with the capital letter M. We look at the you can have some porridge and translate that with the capital letter P. So the complete translation is P horseshoe M. You can have some porridge only if you eat your meat. Has the same logical meaning as if you have some porridge, then you eat your meat. Another example, only if you study hard will you get an A. This is somewhat less common, but it does happen. The only if can occur at the beginning of the English sentence. It still indicates the consequent of the conditional though. So what's going to happen here is there will be two simple statements that follow the only if. The one immediately after the only if, which is you study hard, that will be the consequent of the conditional that comes after the horseshoe in our translation. And then the second simple statement, which will come at the end of this sentence, will be the antecedent that comes before the horseshoe. So only if you study hard. You study hard, we've translated with the capital letter S, and that goes after the horseshoe. Then the last part of that sentence is, will you get an A? That's basically saying you will get an A. And that's translated by the capital letter A. Because it comes at the end of that sentence, it's actually going to be the antecedent of the conditional. So the capital letter A, which stands for you get an A, goes before the horseshoe. Another example, you can register to vote only if you're 18 or older. So this one has the more typical order for only if. It occurs in the middle of a sentence. The capital letter V stands for the proposition or the statement, you can register to vote. The capital letter E stands for the statement, you're 18 or older. So in that case, V horseshoe E translates the proposition because what follows only if has to be the consequent that follows the horseshoe in our translation. Another aspect of conditional statements is the concept of sufficient and necessary conditions. Each conditional statement expresses a relation between two statements in which one of them is the sufficient condition for the other and the other is the necessary condition for the first. A sufficient condition is a statement whose truth guarantees that another statement is true. It's indicated by the word if. So the antecedent in a conditional statement is expressing a sufficient condition for the consequent. Example, being a triangle is a sufficient condition for being a polygon. You could express that with the proposition, if a shape is a triangle, then it is a polygon. So you'll notice we're using the capital letter T to stand for the statement, a shape is a triangle, and the capital letter P to stand for the statement, the shape is a polygon. And so we can express the idea that being a triangle is a sufficient condition for being a polygon by the logical expression T horseshoe P. A necessary condition is a statement whose truth is required in order for another statement to be true, and it is indicated by the term then or by the phrase only if. So it corresponds to the consequent of our conditional. Example, being a polygon is a necessary condition for being a triangle. What this means is a shape is a triangle only if it is a polygon. So we can translate this by the same logical expression as before. When we have the expression T horseshoe P, we would say that being a triangle, or T, is a sufficient condition for being a polygon, and being a polygon, which is the consequent, is the necessary condition for being a triangle. The last logical operator that we're going to learn is the biconditional, which is symbolized by a triple bar. You could think of it as a variant of the equals sign. Now, the biconditional is not expressing a literal equality or identity between the two statements, but it's basically expressing two conditional relations. So you're saying that two conditionals are true. If the first proposition is true, then the second proposition is also true. And if the second proposition is true, then the first proposition is true. So here are some examples of that biconditional relation. It's typically indicated by the phrase if and only if. A shape is a circle if and only if it is a round plane figure whose boundary consists of points equidistant from a fixed point. This is an example of a definition, and definitions are generally expressed logically by a biconditional because you're having a term and then you're having the definition of that term, and if the term being a circle applies to something, then that complete definition should apply to it as well, and vice versa. Also, notice that there can be different ways of expressing the idea of biconditional. If and only if is the most common. Another one you sometimes see is the phrase just in case. So let's try it out on this example. A shape is a circle just in case it is a round plane whose figure whose boundary consists of points equidistant from a fixed point. Another thing to keep in mind is that the phrase if and only if, it is not the same as the phrase only if. Only if just indicates a simple conditional. When you have the phrase P only if Q, you use the horseshoe to translate that. You only use the triple bar if you have the complete phrase if and only if. So P if and only if Q would be P triple bar Q. Another example, you will earn an A in this course if and only if you score 900 points or more. We're using the capital letter A to stand for the statement you will earn an A in this course, and the capital letter P to stand for the statement you score 900 points or more. So let's look at some sample problems. What we want to do is first begin by recognizing the logical operator words. In this case, she will be happy unless her date is a jerk. Remember that the word unless indicates the logical idea of or. So we want to circle that, and then as a reminder, we can put above it the logical operator that word or phrase expresses. Now, once you get some practice, or perhaps already, you may be able to translate these using symbols without having to make any notes on the statement. But I'm going to be making notes on the statement itself to give you guys tips for how to break down a statement into its logical parts. After you've identified all the logical operator words in a statement, then you want to underline the simple statements. So in this case, the first simple statement is she will be happy. We could symbolize that by H. The second simple statement is her date is a jerk. We could symbolize that by a J. Bringing this together, our translation is H, wedge, J. She may not look like much, but she can reach 0.5 past light speed. So we begin by identifying all the logical operator words we can find. The first one is not, which is going to be symbolized by the tilde. The second is but, which is going to be symbolized by the dot for and. And then we identify the simple statements. She may look like much. That's going to be symbolized by a single capital letter like L. And then the second simple statement is she can reach 0.5 past light speed. And perhaps we could symbolize that by the capital letter R. So then bringing this all together, it's going to be tilde L dot R. Remember, you do have a choice in terms of which capital letter to translate each simple statement with. Once you've used one capital letter in one problem or one argument, you need to be consistent and use it for that simple statement if it recurs. And also, it's customary to choose a capital letter that reminds you of one of the main words, like the subject or the main verb in the statement that you're translating. And then finally, you want to make sure that your translations of simple statements really are simple statements. So make sure there's no kind of like logical word, no not, or and that might be hiding in the simple statement. In this case, though, we haven't missed any logical operators, so we can finish. I will deduct 10% only if your paper is turned in late. So the first logical operator is only if. This is a conditional, a way of expressing a conditional, so we're going to symbolize it by the horseshoe. There do not appear to be any other logical operators in this statement, so we look for our simple statements. I will deduct 10%. We can symbolize that by the capital letter D. The next simple statement, your paper is turned in late. We can symbolize that by the capital letter L. Remember, the phrase only if indicates the consequent or second part of the conditional. So what follows it will go after the horseshoe. So bringing this together, the complete translation is going to be D, horseshoe L. You can have dessert only if you eat your greens. So once again, we look for the logical operator phrases. Another only if. So that's going to be the horseshoe. You can have dessert. That is a simple proposition, which we could symbolize by the letter D. You eat your greens. Another simple proposition, which we can symbolize by the letter G. So bringing this together, it's going to be D, horseshoe, G. Now imagine a scenario where we had just the word if in the middle of a sentence. You can have dessert if you eat your greens. In that case, the phrase that follows the if would be the antecedent. It would go before the horseshoe. So the complete translation would be G horseshoe D. But in this case, we do have the complete phrase only if in the middle of the sentence. So it does indicate the consequent of the conditional. What follows the only if will go after the horseshoe. There can only be a fire where there is oxygen. Now, this is an unusual way of expressing a logical concept, and it may be difficult for you to identify what the actual logical operator is. The main clue is the word only, and it should remind you of the phrase only if. Instead of only if, though, this is expressed by only where. Now this is unusual, and I probably wouldn't use this in an exercise or exam just because it is somewhat atypical, but you need to be aware of the variety in which logical ideas can be expressed. So this whole concept, only where, is going to be equivalent to a conditional or an if-then statement. It's more common though for the if concept to be expressed by the word when. This is a rare case where it's expressed by the word where. And now there do not appear to be any other logical operator terms, so we can look for our simple statements. There can be a fire. We could use the letter F to translate that for fire. There is oxygen. We can use the letter O to translate that for oxygen. So the complete translation of this is going to be F horseshoe O. And we can reword this to understand that this is the correct translation. F horseshoe O can also be expressed as if there is a fire, then there's oxygen. Also, we could say there is a fire only if there is oxygen. And both of those you can see have the same basic meaning as there can only be a fire where there is oxygen. So it gives us further confirmation this is the correct translation. Your car will get stuck on the speed bump if and only if it is a lowrider. So as before, we want to look for the logical operator. In this case, it's the whole phrase if and only if. And that is symbolized by the triple bar. Now let's look to see if there are any other logical operator terms. There don't appear to be. So let's look for our simple statements. Your car will get stuck on the speed bump. We could symbolize that by S for stuck. It is a lowrider. We could symbolize that by R for low rider. And bringing that together, it's going to be S triple bar R. So whatever comes before the if and only if, you can put before the triple bar. And whatever comes after the if and only if, you can put after the triple bar. Now let's look at a problem involving necessary and sufficient conditions. This is just a kind of reminder of the logical relations between the antecedent and a consequent in an if-then statement. In order to keep it track, what is the if clause and what is the then clause, it may be helpful to start by translating the proposition as with our other problems. So we identify our logical operator terms, if and then. Those go together, so they're going to be expressed by one horseshoe. Then we look for our simple propositions. An atom has exactly one proton. That's going to be O for 1, and it's a hydrogen atom. So we can symbolize that by the letter H for hydrogen. So because the O comes after the if and before the then, it's going to go before the horseshoe. And in terms of necessary and sufficient conditions, the if clause is the one that's going to be the sufficient condition for the other statement. So in this case, we would say having exactly one proton is a sufficient condition for an atom being hydrogen. And being hydrogen is a necessary condition for having exactly one proton. That's the logical idea that's expressed by this particular statement. So as a reminder, whatever the if clause is, that's going to be the sufficient condition. Whatever the then clause or consequent is, that will be the necessary condition. Another example, you live in the White House if you're president of the United States. So once again, let's start with the translation by identifying our logical operator word, if. That will be translated by a horseshoe. Then we can identify our simple statements. Do you live in the White House? We can symbolize that by W for White House. You're president of the United States is another simple statement. We can symbolize that by P. In this case, however, the if is alone in the middle of the sentence. We have to remember that when we have the if in the middle of the sentence, then what follows the if is going to go before the horseshoe. The if clause always goes before the horseshoe because the word if by itself indicates the antecedent. So this will be translated as P horseshoe W. As before, the antecedent, in this case P, is going to be the sufficient condition. So being president of the United States is a sufficient condition for living in the White House. Living in the White House is a necessary condition for being president.